我2023年嘅 Paper 1B 第10條呢，又係我最喜歡嘅題目啦。呢條題目啦，唔單止跨課題，又有埋數據分析，最緊要嘅就係有埋睇病學 BIO添，真係唔愛死你都唔得啦。咁我哋睇一睇題目先咯。題目咧就講啦，介紹咗一款農作物啦，就叫木薯啦。佢就係一個雨量少啦、土壤貧瘠嘅地方咧去成長嘅，而佢係會生產到一個充滿澱粉質嘅塊根。而木薯咧喺非洲咧亦都係一個主要嘅食糧嚟嘅。咁 Part A 啦，非常之直接嘅題目啦，就問翻呢，其實澱粉質呢要喺我哋嘅人類消化系統嗰度消化噶嘛，咁究竟個化學式消化喺邊度發生嘅呢？咁呢條題目啦，自不然就係考翻我哋化學式消化啦。咁喺我哋個消化系統當中啦，其實有關於澱粉質嘅消化，不外乎嘅就係口腔啦，同埋小腸啦，亦都借住呢個機會啦，同大家溫一溫書啦。今次題目咧就係問翻消化管道嘅位置啫。下次問下啦，喂，要加速翻澱粉質消化嗰隻酶叫咩名啊？咁自不然啦，就係澱粉酶咯。咁澱粉酶啦，究竟喺個口腔、喺個小腸啊有咩分別呢？喺口腔嘅咧就係唾液嘅澱粉酶，喺小腸嘅咧就係胰液嘅澱粉酶啦。咁你有心理準備咯。唔一定要問你消化管道位置噶嘛，我講到明噶啦，喺口腔啦，喺小腸啦，都有呢啲酶嘅。咁呢啲酶叫咩名啊？咁你要識噶咯。跟住啦，去到 Part B 咧，就係數據分析嘅題目啦，零零舍舍要我哋計數嘅題目咧，就俾咗2個表格我哋嘅。第一個表格咧就係有關於木薯嘅營養價值啦。原來啦，我哋要抽取咗100克嘅乾重嘅木薯咧，我哋需要250克鮮重嘅木薯嘅，而每100克乾重嘅木薯咧就有2675 kJ 嘅能量啦，同埋啦亦都有3.5克嘅蛋白質嘅。而去到第二個表格啦，就顯示咗一個16歲嘅男仔啦，佢嘅日常能量啦同埋蛋白質嘅需要11100個 kJ 啦，同埋52克嘅蛋白質嘅。我哋入題目咯噃，喺非洲咧有啲低收入嘅家庭咧，佢哋主要啦就係依賴咗木薯作為佢哋嘅主要食糧嘅。咁第一部分咧，佢就講翻一個16歲男仔咧，佢就淨係食木薯嘅啫。咁題目就要我哋去計翻啦，究竟佢要食幾多鮮重嘅木薯先能夠滿足到佢日常嘅能量需要呢？咁呢條數式咧就俾咗大家先啦，有3個數字咧我哋要知道嘅。第一啦，就係佢每一日需要幾多能量啦，11100嘅 kJ 啦。第二啦，就係每100克嘅乾重嘅木薯，究竟能夠俾到幾多能量佢啦，就係2675 kJ 啦。除咗之後啦，其實就即係講緊究竟佢要食幾多乾重嘅木薯啊嘛。咁但係題目唔係問幾多乾重啊嘛，係問幾多鮮重啊嘛。所以啦，就要乘翻250克咯，因為啦，每250克鮮重嘅木薯蒸乾晒啲水分之後啦，就能夠獲得到100克嘅乾嘅木薯啊嘛。所以啦，條數式就係11100除翻2675，再乘翻250。咁答案咧就係1037.4克啦，大約1公斤啦，係咪？咁呢條題目啦，有咩變奏呢？問完啦，食幾多新鮮嘅木薯去滿足能量需要？咪問下你咯，食幾多新鮮嘅木薯先可以滿足到蛋白質嘅需要呢？咁其實啦，你見到條數式咧都係非常之相近噶。每一日你需要幾多嘅蛋白質啊？52克。咁每100克嘅乾重嘅木薯能夠俾到幾多蛋白質你啊？3.5克，再乘翻250克，答案呢就係3714.3克嘅鮮重木薯，接近係4公斤，咁先滿足到蛋白質嘅需要，都幾多下喎，係咪？咁其實大約你都諗得到噶啦。如果佢淨係食1公斤嘅鮮重木薯呢，夠唔夠滿足佢日常嘅蛋白質需要呢？應該係唔夠嘅，因為佢應該要食接近4公斤嘅鮮重木薯先滿足到佢嘅日常蛋白質需要，係咪？ 跟住啦，去到第二部分啦，佢就話啦，當呢個男仔啦食木薯食咗一段長時間啦，佢就發現佢隻腳呢因為組織液嘅積聚而腫脹咗。第一部分啦，就要我哋計數啦。喂，咁究竟呢，佢淨係食呢個大約1kg 嘅鮮重木薯，究竟獲得到幾多嘅蛋白質呢？所以啦，今次條數式呢係同第一部分嗰條數式係極度相近嘅。頭嗰部分呢都係用翻個能量嘅，11100除翻2675，但後尾乘就唔係乘鮮重咯。咁喺呢100克嘅乾重木薯入面有幾多蛋白質啊？咪乘翻3.5 gram 咯。所以答案呢就係14.5 gram。咁你會發現啦，哇，食得好少喎。你正常都要52啦，你而家得14.5啫，真係唔夠，係咪？咁呢個啦就有關於第二部分要問你嘅嘢啦。咁啊，有關於計數嘅，不厭其煩又提大家啦。計數要單位是常識吧，係咪？再加上啦，嗱，今次題目咧都係1分1分啫。下次俾多1分你，變成2分題目嘅時候呢，你就隨時要俾埋個步驟我噶咯。咁今次啦，你寫埋步驟俾我好唔好呢？其實我覺得呢都好嘅，寫定步驟撳機咯。嗱，你撳機唔好撳錯啦，咁啊自不然答案呢都應該啱噶啦。然後啦，去到第二部分咯，根據翻第二個表格啦，就要我哋預測一下啦。呢個男仔佢同一個正常健康嘅同樣歲數嘅男仔比，佢哋嗰個血液蛋白質水平會有咩唔同呢？然後解釋你嘅答案。咁呢個題目啦，究竟我哋點樣鋪排？有2個步驟嘅。第一步驟就係人哋要你預測個不同啊嘛，咁梗係要講咗個不同先啦，係咪？咁既然講個不同嘅話啦，自不然就係比較嚟噶咯，完整比較。究竟啦，呢個長時間食木薯嘅男仔，佢嗰個血液蛋白質水平係高過定係低過一個正常健康男仔呢？講完個分別之後啦，我哋就解釋咯。咁其實啦，佢嘅血液蛋白質水平呢，應該係比一個正常健康男仔嘅血液蛋白質水平應該為之低嘅。咁點解啊？去到第二部分啦，啱啱計數先計過，咗個大約1公斤嘅木薯呢，佢只係獲得到14.5克嘅蛋白質嘅啫。但係正常每一日佢需要嘅係52克嘅蛋白質啊嘛，咁擺到明就唔夠啦，係咪？所以啦，因為佢嘅蛋白質攝取量較建議嘅每日需求為之低，所以啦，佢嘅血液蛋白水平呢，亦都較平常嘅人為之低啦。咁你會問啦，喂，梁 Sir， 其實呢，我頭先計咗數噶嘛，而家表格二嘅數我有噶嘛，我照抄嘅啫嘛。其實我寫落去得唔得噶？因為佢嘅蛋白質攝取量就係14.5克，係遠低於佢嘅建議每日嘅蛋白質需求就係52克。所以啦，呢個男仔嘅血液蛋白質水平呢，就會比一般人為之低咯，直頭係完美嘅答案添啦，係咪？所以啦，有數字呢，你計啱數呢，唔怕寫埋落去嘅。跟住去到第三部分啦，環環相扣啦。根據翻第二部分嘅答案就係呢個男仔佢嘅血液蛋白質水平比正常健康嘅男仔為之低啊嘛。咁究竟呢個現象啦，係點解會導致到佢嘅組織液會喺個腳度積聚起上嚟呢？從而導致隻腳腫咗呢？咁呢條題目啦，自不然就考翻我哋有關於組織液嘅形成同埋回流咯。咁組織液點樣形成嘅呢？係根據壓力不同所形成嘅，係喺個微血管入面嘅血壓啦、水壓啦，比起身體細胞周圍嘅液體嘅壓力為之高，所以啦就逼咗啲水分啦、細粒嘅分子啊，例如啦葡萄糖啊、氨基酸啊、礦物質啊，就會離開咗個血液，離開咗個血管，形成組織液咯。而組織液嘅回流呢，係透過滲透所導致嘅。當中啦，我哋就睇翻呢幅圖咯。以前我哋解題呢都解過噶啦。原因呢，就係因為組織液嘅水勢係比起血液入面嘅水勢為之高，所以啦啲水分呢就會由組織液回流翻去血管入面啦。咁所以啦，成條題目最關鍵嘅概念呢，就係點解個腳或者我哋嘅身體組織啦，嗰啲組織液會積聚起上嚟呢？原因好簡單，就係因為組織液嘅形成嘅速率 係快過組織液回流嘅速率啦。但係整條題目唔係淨係講呢句咁簡單啊嘛，要根據翻第二部分嘅答案啊嘛。所以啦，我哋整個思考鷹架就要做多一步啦，就係點解組織液回流咁慢呢？同佢個飲食有咩嘅關係呢？咁我哋就會發現啦，原來血液蛋白嘅水平低，就會令到靜脈末梢嘅微血管網嘅水勢亦都較為高喎，因為佢冇咁多溶落水嘅溶質啦嘛，係咪？血液蛋白係溶到落水嘅，所以越係多血液蛋白嘅話呢，其實水勢係低嘅。咁但係而家佢冇乜血液蛋白，即係冇乜溶質喺入面嘅話呢，咁溶質嘅濃度低，咁水勢咪高咯，係咪？咁血嘅水勢咪會高一啲咯，所以就會導致到組織液入面嘅水分回流翻入去靜脈末端嘅微血管網嘅量呢，就會減少啦。所以啊，組織液嘅回流呢，就會慢過組織液嘅形成咯。咁呢個題目呢，都有唔少同學呢係諗漏咗嘢嘅，佢哋呢係知道個概念嘅。組織液嘅水分之所以能夠回流翻去血，係因為滲透。咁滲透之所以出現得到，係因為水勢有分別啊嘛。但係點解會水勢唔同呢？原來就係因為喺個血液入面嘅蛋白質水平啊，喺個血液入面嘅血漿蛋白水平係比一般人為之低啊。你就未做到呢個扣連。所以啦，佢哋答嘅咧都係較為空泛嘅，就係水勢有唔同咯。OK， 水勢係有唔同，但係點解水勢會唔同呢？咁佢哋答得到個水勢有高低，但係點解水勢有高低之分呢？點解會導致到組織液嘅回流係會慢咗呢？咁過往啦，除咗組織液之外咧，仲有淋巴系統啊、水嘅流動啊，咁過往都有唔少題目嘅。咁啊，快手睇下片，溫下書咯。要去到 Part C 咧，繼續睇病學 Bio啦。原來木薯咧係有啲天然嘅毒素嘅。如果啦你食咗嗰啲木薯係未經煮熟嘅話咧，你係有機會氰化物中毒，亦即係生埃中毒啦。原來生埃咧係會抑制咗一啲酶嘅，而呢啲酶咧係參與咗喺呢個氧化磷酸化嗰處，所以氰化物或者生埃咧係能夠停止咗氧化磷酸化嘅。咁去到 Part 1咧，又係好直接嘅題目啦。究竟啦呢一款被抑制咗嘅酶啊，喺我哋嘅粒線體嘅咩嘅結構嗰度嘅咧？我喺邊度揾到佢嘅咧？咁呢個題目啦，就梗係考翻啦，有關於氧化磷酸化，究竟佢喺我哋嘅細胞，喺我哋嘅粒線體嘅邊度發生呢？答案啦，就係粒線體嘅內膜。咁不厭其煩啦，提下大家啦，氧化磷酸化佢係一個氧化還原反應嚟嘅。而呢個氧化還原反應咧，係需要酶咧去催化，而呢啲酶咧就喺個粒線體嘅內膜，所以答案呼之欲出啦，就係內膜或者矽啦。矽咧 ，Christi 係單數 ，Christa 係眾數，都係解做粒線體嘅皺摺，即係呢個內嘅接曲面啦，接起上嚟好似個山嘅山脊接起咗嘅，咁呢個咧就叫做 Christi 啦。跟住啦，呢條題目有咩變奏呢？就係反翻轉問你咯。而家題目就講啊嘛，有款酶呢，就係被呢個氰化物抑制咗嘅，從而啦就係去停止咗咧呢個氧化磷酸化。咁究竟呢隻酶喺邊度揾到啊？好直接啦，係咪？下次反翻轉咯。原來有隻酶呢，係喺呢個粒線體嘅內膜嘅，而呢款酶呢，係會俾個氰化物去抑制嘅。咁喺個衰氧呼吸嘅邊一個步驟係會被抑制啊？其實我問緊同一樣嘢啫嘛，不過反轉嚟問你啫嘛，係咪？跟住啦，去到第二部分咯。有個人呢，就意外地啦食咗啲生嘅木薯咁究竟啦喺佢個血液嘅乳酸水平會點樣變化呢？升咗啊，高咗啊，不變啊？然後解釋你嘅答案。呢個題目呢，就係考翻我哋缺氧呼吸嘅概念啦。缺氧呼吸係咩意思啊？氧化磷酸化做唔到 ，Krebs cycle 做唔到，淨係做到 glycolysis 啫。所以題目就係考翻我哋有關於 glycolysis 啦、缺氧呼吸啦，同埋乳酸發酵嘅概念啦。咁當中咧，整條題目嘅思考邏輯，第一部分我哋就講啦，究竟血液嘅乳酸水平會點樣變化？究竟會點樣變化？升高定減少啊？會升高嘅。但係呢條題目有一個細節位。 除咗講血液嘅乳酸水平上升，你仲要解釋噶嘛。所以啦，有一部分你都要解嘅就係點解啲乳酸會去咗個血嗰度呢？所以啦，呢條題目你會發現啦，除咗我講咗血液嘅乳酸水平有所增加之外呢，我亦都要提及到呢，血氧呼吸所產生嘅乳酸或者乳酸鹽呢，係會被釋放到血液。咁血液嘅乳酸水平先會上升噶嘛，係咪？你唔講呢句，淨係話啦，血液嘅乳酸水平會上升，然後加埋個解釋啦，咁啊因為呢，氧化磷酸化呢就做唔到啦，而佢嘅身體細胞呢就改用缺氧呼吸去獲取能量，或者淨係依賴糖酵解去釋放能量，所以啦，佢嘅血液嘅乳酸水平咪上升咯，係唔夠噶，係因為啲乳酸都要釋放咗呢個血嗰處，先能夠增加到血液嘅乳酸水平噶嘛，係咪？好，跟住啦，嚟到一點出發啦。成條題目咧就由木薯開始。今次咧冇問特別多嘅，就係問有關於塊根嘅嘢啦。儲存食物題目都俾咗你，下次攞嚟問埋你營養繁殖、無性繁殖得唔得啦？梗係可以啦。然後啦，題目就問我哋有關於消化啦，同埋呼吸作用咯。有關於消化咧，喺個木薯入面，我哋有3個部分我哋要理解嘅。第一啦，澱粉質啦；第二啦，能量啦；第三啦，蛋白質啦。有關於消化部分呢，就係問澱粉質嘅。今次就問化學式消化，下次問機械式消化得唔得啦？梗係可以啦。第二啦，有關於能量咯，究竟啦呢個男仔淨係靠木薯吸唔吸收夠足夠嘅能量噶？咁原來啦都要食1公斤嘅鮮重木薯先有足夠嘅能量攝取。而有關於能量攝入同輸出呢，就關佢會唔會變輕或者變重事咯。原來蛋白質都有需求噶嘛，所以啦，當我哋食嘢嘅時候，除咗能量嘅需求，亦都有營養嘅需求咯。呢一 part 講住咁多先，去到呼吸作用啦。粒線體嘅結構係點樣噶？有外膜啦，有內膜啦，有脊位啦，有唔同嘅酶啦。咁成個粒線體佢有咩適應性特徵呢？粒線體有啲內膜喺度接下，有咩咁緊要呢？咁其實過往我哋都有一條題目，粒線體係同繁殖有關係嘅。咁啊，快啲睇下片，溫下書咯。有關於呼吸作用，當然亦都有製造 ATP 啦。我哋有衰氧嘅呼吸啦，缺氧嘅呼吸啦。咁過往都有唔少題目噶啦。究竟啦，製造 ATP 啊，製造 CO2 啊，製造林種嘅嘢。咁啊，快啲睇下片，溫下書咯。完咗呢2 part 之後，就去到我最中意嘅睇病學 Bio啦。先睇翻樓上營養先，食唔夠蛋白質噶嘛，係咪？你營養需求唔得，不均衡飲食，引致缺乏症。今次係蛋白質缺乏症 ，Kwashiorkor 呢個名你記唔記得呢？或者下次題目有咩嘅變奏啊？就問下你啦。如果一個人食唔夠蛋白質嘅時候，叫你指出同埋解釋一下，對於呢個患有蛋白質缺乏症嘅人啦，我哋有啲咩嘅特徵係能夠睇得到出嚟嘅呢？個腹部腫脹咗啦，隻腳腫脹咗啦，肌肉會好少啦，肌肉萎縮咗啦，成長得好遲緩啦，好慢啦，貧血啦，或者抵抗力好弱啦。點解會咁樣嘅呢？你又試下喺留言區留低你嘅答案，睇下你嘅 concept 清唔清？而除咗食嘢之外啦，原來酶嘅抑制咧都關睇病學 Bio 事嘅，因為今次係會死人噶。原來食錯咗氰化物山埃之後咧，會抑制咗你嘅衰氧呼吸，焗你行缺氧呼吸，你夠唔夠能量供應啊？唔夠能量嘅一刻，你會死人噶。所以點解我話呢條題目我咁中意？有跨課題，又有數據分析，又有睇病學 Bio 啦。所以你話呢條題目我幾咁中意呢？又有跨課題，又有數據分析，同埋最緊要係有咩啊？睇病學 Bio 啊！ 223 Paper 1B Question 10 is my favorite question. It's a cross-topic question, data analysis question, and disease approach. So let's take a look at the question. Cassava is a crop which grows in an area with poor soil and a low rainfall. It produces starchy root tubers, which serve as a major food source in Africa. So for part A, very straightforward question. give the locations where the chemical digestion of the starch takes place in the human digestive tract. So this question, it checks us the concept about the chemical digestion. Surely we know that it should be mouth cavity or small intestine. So next part, I want to do the revision with you. So we need to realize the enzymes, the amylase, they are involved in the starch chemical reaction. This time, it just asks you the location of the human digestive tract where the starch chemical digestion takes place. So what about next time? I ask you the name of the enzyme involved. So in the mouth cavity, it should be the salivary amylase get involved. And in the small intestine, it should be the pancreatic amylase, which is in the pancreatic juice. They are get involved. So for part B, it is about the data analysis calculation question. Table 1, it shows the nutritional information of the cassava, and the table 2, it lists the daily energy and protein requirement recommended for boys at age 16. How can we understand table 1 and 2? For the table 1, if we want to obtain 100 gram dry weight of cassava, we need 250 grams fresh weight of the cassava. Per 100 gram dry weight of cassava, it contains 2,675 kJ, and there are 3.5 grams protein per 100 gram dry weight of cassava. For table 2, it shows the daily energy requirement, 11,100 kJ and 52 grams protein. So for the question, in Africa, some low-income families may only rely on cassava for food for a long period of time. So in part 1, a 16-year-old boy relies only on cassava for food. Calculate the fresh weight of cassava he needs to consume so as to meet the recommended daily energy requirement. So for this question, we need to know that how can we calculate it? We need 3 data. First of all, the daily energy requirement, 11,100 kJ. And then per 100 gram dry weight of cassava, how much energy can he obtain? He can obtain 2,675 kJ. So from this part, we can calculate the dry weight of cassava he needs to eat in order to meet the daily energy requirement. However, the question is asking the fresh weight of the cassava. So we need to know that. So we need to know that if we want to obtain 100 gram dry weight, what we need 250 grams fresh weight of cassava. So that's why we have this equation. Therefore, we have this formula, 11,100 kJ divided by the 2,675 kJ and times 250 grams. So the final answer is 1,037.4 grams, around 1 kg, right? So any possible question variation? After we calculate the fresh weight of cassava he needs to consume so as to meet the recommended daily energy requirement. So what about the daily protein requirement? You can see the logic, they are the same. Daily protein requirement, 52 grams, divided by the protein intake per 100 gram dry weight of cassava, 3.5 gram, times the fresh weight, 250 grams. So the answer will be 3,714.3 grams. So you can imagine that, what if this boy only intake 1 kg fresh weight cassava? Is it enough for him to meet the recommended daily protein requirement? Surely not. So we move on to part 2. After consuming cassava only for a period of time, this boy develops swollen feet due to the accumulation of tissue fluid. So for part 1, how much protein can he obtain from the amount of cassava consumed in part 1, around this 1 kg cassava? You have this concept, daily energy requirement divided by the energy intake per 100 gram dry weight. So we have the dry weight of the cassava intake, and then times the protein. So finally, we have the 14.5 grams. You can compare the number very briefly. It's much lower than the daily protein requirement. Very insufficient. Before we move on, I would like to remind you that no unit, no mark. This question only carries 1 mark. So if you only give me the number but without the unit, 0 mark directly. What if the question gives you 2 marks and then you need to show the steps as well? So no matter what, when you are doing the calculation question, what you need the formula, you need the steps, answer, and the unit. And then for part 2, according to table 2, predict the difference of the blood protein level of this boy when compared with that of a normal healthy boys of the same age, and explain your answer. So how can we construct our answer? Step 1, we need to state the difference of the blood protein level of this boy when compared with that of a normal healthy boys of the same age. Second step, we need to explain the difference based on part B1 and the table 2. First of all, we need to do the comparison, right? It means that we need to do the comparison. And when we are doing the comparison, surely it should be the complete comparison. For this boy consumed cassava for a long time. So for this boy consumed cassava only for a long time, his blood protein level is higher or lower than that of the normal healthy boy. And step 2, we need to explain. So we need to use the part B1 and the table 2 to get the idea. So from the part B1, the boy obtains only 14.5 grams protein from the diet. However, the daily protein requirement is 52 grams. So you can see that his protein intake is much lower than the recommended daily protein intake. Therefore, his blood protein level should be lower than that of the normal healthy boys of the same age. So that's the idea. So it would be nice that you can mention the data, the number in your answer to make it more comprehensive. And then for part 3, based on your answer in part 2, explain why this would lead to the accumulation of the tissue fluid in his feet. So you can recall the concept of the tissue fluid formation and the removal. So surely this question is checking us the concept about the tissue fluid formation and the removal. For the formation of the tissue fluid is due to the pressure difference. The hydrostatic pressure or the blood pressure in the capillaries is higher than that in the intercellular fluid. Therefore, the water, the small molecules such as glucose, amino acid, the minerals, they are forced out of the capillaries. And then the fluid, it forms tissue fluid. And then for the removal of the tissue fluid is due to the osmosis. And the reason is that the water potential in the tissue fluid is higher than that in the blood. Therefore, the water molecules, they will move back, return to the blood capillaries. So the critical concept of this question is talking about the accumulation of the tissue fluid in the feet. That means the body tissues. The reason is that the rate of the formation of tissue fluid is higher than the rate of the removal of the tissue fluid. Anything we also need to mention, we need to relate the human diet to the lower rate of the removal of tissue fluid. So the low blood protein level leads to a high water potential than normal at the farthest end of the capillary network. So you know that the blood protein, the plasma protein, they are water soluble. Therefore, they will lower the water potential of the blood. However, when the blood protein level is lower, it means there are less solute. So the concentration of the solute is lower, so the water potential of the solution will be higher. That's the very basic concept we need to know. And then the amount of the water in tissue fluid returning to the blood and the venous end of the capillary will be reduced. Why there is an accumulation of the tissue fluid in the feet. And I would like to mention the common misunderstanding. Many candidates were not aware that the return of the water from tissue fluid into blood depends on the water potential difference result from the blood protein level or the plasma protein level. They can talk about osmosis. They can compare the water potential difference, but they cannot tell the reason of the water potential difference. So apart from tissue fluid, there were also questions about the lymphatic system or the water movement. So watch the video and do the revision. Then for part C, we continue the disease approach. Cassava contains a natural toxin Consuming inadequately cooked cassava may result in cyanide poisoning. So cyanide shuts down the oxidative phosphorylation in mitochondria by inhibiting a key enzyme of the process. So for part 1, very straightforward question. Name the structure of the mitochondrion where this enzyme is located. So we need to recall the location of the oxidative phosphorylation of the aerobic respiration. It is in the inner membrane of the mitochondria. Because for the oxidative phosphorylation, it's a series of redox reactions catalyzed by the enzymes embedded in the inner membrane of mitochondria. So the answer is inner membrane or the cristae. Cristae is the singular, crista is the plural. It means the fold or the foldings in the inner membrane of the mitochondria. And it's just like this folding part of the mountain. So any possible question variation is given that the enzyme embedded in the inner membrane of the mitochondria are inhibited by the cyanide. So state the corresponding stages of the aerobic respiration is being inhibited. So you can see that I just reverse the question and ask you, no matter for the inner membrane of the mitochondria or ask you the oxidative phosphorylation, the same idea. And then for part 2, a man accidentally consumes some raw cassava. How will his blood lactate level change? And explain your answer. So we need to recall the concept of the anaerobic respiration, oxidative phosphorylation, Krebs cycle, they cannot be performed. And then we need to recall the concept of the lactic acid fermentation. Glucose undergoes glycolysis and is oxidized to pyruvate. NADH and ATP are formed, and the pyruvate is reduced to lactic acid by NADH. It is the lactic acid fermentation, right? So for the thinking logic, question 1, how will his blood lactate level change? Surely you need to tell me what is the change, increase or decrease. So his blood lactate level will increase. Yes, I know, but how do they, that means the blood lactate, enter the blood? So you need to tell me that the lactate or the lactic acid will be produced in the anaerobic respiration and be released into the blood. If you do not mention be released into the blood, somehow you cannot really tell me that the blood lactate level increases. You just say that, oh yes, the lactic acid, they are produced, that's all. So for the explanation, why are the lactate being produced? As the oxidative phosphorylation is shut down. Keep watching me shut it down. His body cell will switch to anaerobic respiration to obtain energy or rely on glycolysis for energy release. It's the reason why are the lactic acid being produced. So let's talk about the curriculum mapping. First of all, we talk about the cassava. Question did not ask that much. It's about the root tuber, food storage. But what about next time it asks you the vegetative propagation? And then the question asks you about the digestion and the respiration. For digestion, it's about the starch, energy, and protein. Particularly for starch, we talk about the mechanical or the chemical digestion and the certain location of the human digestive tract. And then for the energy, when we are talking about the energy intake and output, so it will need to weight gain or weight loss. And for the protein, it's about the nutritional requirement. After that, we talk about the respiration for the mitochondrion. What is the structure, any adaptive features? For example, for the highly folding inner membrane of the mitochondrion, the crista, the cristae. So any benefit, any importance of this structure, the adaptive features, right? So apart from the respiration, there was a question also about the mitochondrion, but the main theme is about reproduction. So watch the video for revision. And for the respiration, surely we talk about the ATP production by no matter aerobic and anaerobic respiration. So you can refer to the MC before, no matter about the ATP production, the CO2 production, NADH production. So you need to do revision about that. And after that, surely for the disease approach. For the protein, for the nutritional requirement, the African boy, they cannot obtain sufficient amounts of protein. So there will be unbalanced diet and they will suffer from the deficiency disease. This time we are talking about the kwashiorkor. So, any possible question variation? State and explain any sign of the kwashiorkor based on the insufficient protein intake. For example, swollen abdomen, muscle wastage, retarded growth, anemia, and weak immunity. Apart from the deficiency disease, the inhibition of the enzyme is also related to the disease approach, which are involved in the oxidative phosphorylation they are inhibited, so you are forced to perform the anaerobic respiration. But can you produce sufficient energy by the anaerobic respiration? No. For if someone is suffering from the cyanide poisoning, he or she will die.